Hi, this is Venu Babu, Chemistry from PSR Pinnacle classes. Today we discuss about buffer solutions. So buffer solutions. What is buffer solution means? The solution which can resist the change in pH value by addition of small amount of strong acid or strong base or on dilution is said to be a buffer solution. If you are adding small amount of strong acid or small amount of strong base or on dilution, there is no change in pH value. That means this solution contains some reserve acidity and reserve alkalinity. That means some reserve acid, some reserve base is present. Due to this, if you are adding small quantity of acid, that reserve base neutralizes that acid. If you are adding small quantity of strong base, that reserve acid neutralizes that base. So that's why there is no change in pH value. Such solutions are called buffer solutions. These buffer solutions we are used, so our blood contain one buffer, that is carbonated bicarbonate buffer. So that is carbonated bicarbonate buffer is present in HCO3 minus and CO3 2 minus. Is the buffer present in blood maintain constant pH of blood, that is 7.42, because we are taking some acidic drinks, that is like lemon water, orange juice and some spicy food items we are taking, but the pH of blood is not changed because of this buffer. Because of this buffer, the pH of the blood is not changed. If pH of blood is changed nearly 1 unit, then it not act as an oxygen carrier. So that buffer is very important in our blood, that is carbonate and bicarbonate buffer. So not only here, for preservation of biological specimens we are using buffer solutions, and also use it for preservation of food items, so for preservation of agriculture products, and also used in qualitative analysis and quantitative analysis in laboratories, we are using buffer solutions. So these buffer solutions are, buffer solutions are two types, that is simple buffers and mixed buffers. Simple buffers and mixed buffers. Simple buffers, simple buffer, mixed buffers, mixed buffers, mixed buffers. So simple buffer, this mixed buffers again classified into two types. This mixed buffer again classified into two types, that is acidic buffers and basic buffer. Acidic buffer, basic buffer, basic buffer, acidic buffer, basic buffer. What is simple buffer? So simple buffer means it is a combination of weak acid and its salt with, so that is salt of weak acid and weak base act as a simple buffer. Salt of weak acid and weak base act as simple buffer. So this is a salt of weak acid plus weak base act as a simple buffer. For example, ammonium acetate, CH3COONH4. So it acts as a buffer. And ammonium cyanide, it is a salt of weak acid HCl and weak base NH4OH. So it acts as a buffer. For example, AgCN, this also acts as a simple buffer because it is a combination of weak acid AgOH and weak base HCl. So that's why it acts as a buffer. So this is a buffer. This is CH3COONH4. CH3COONH4. So plus H2O, we are getting weak acid CH3COOH and NH4OH. NH4OH. We get weak acid. This is a weak acid. This is a weak base. So it is a salt of weak acid and weak base. It can be act as a buffer. So in this, if you are adding small amount of strong acid or small amount of strong base, there is no change in pH value. So you know this ammonium acetate is a salt. I am writing ionic equation for ammonium acetate as CH3COO minus NH4 plus. So by addition of acid, what happened here? Addition of acid. So acid means you are adding H plus ions. By addition of H plus ions, this acetate ions, CH3COO minus ions, combine with this H plus ions to form feebly ionized, less ionized acetic acid. So there is no increase in H plus ion concentration in solution. Or otherwise, NH4OH solution, NH4OH present in solution combine with this H plus to form NH4 plus H2O. So the added H plus ions are consumed. There is no increase in H plus ion concentration. That's why there is no change in pH value. By addition of base, addition of base, addition of base. If you are adding base, base means you are adding OH minus ions. If you are adding OH minus ions, this NH4 plus ions present in this, NH4 plus ions present in this, combine with added base OH minus ions to form NH4OH, feebly ionized base. So there is no increase in OH minus ion concentration in solution. That's why there is no change in pH value. Or otherwise, this CH3COOH molecules, CH3COOH molecules combine with OH minus to form CH3COO minus plus H2. So the added base OH minus ions are completely consumed. There is no increase in OH minus ion concentration solution. So there is no change in pH value. So this is simple buffer. So for this simple buffer, this is a salt of weak acid and weak base. So for this simple buffer, for calculation of pH, already having formula in salt of weak acid and weak base, pH is equal to 7 plus 1 by 2 into pKa minus pKb. So this is came in salt hydrolysis, pKa minus pKb. This is the calculation of pH of buffer solution in case of simple buffers. So here there is no concentration term. It not depends on concentration of the salt in this case. And acidic buffer and basic buffer. So we can check acidic and basic buffers. Acidic buffer. Acidic buffer. Acidic buffer means it is a mixture of weak acid and its salt with strong base. Weak acid plus weak acid salt of this weak acid with a strong base. Weak acid plus salt of weak acid with strong base act as a acidic buffer. For example, so by direct combination of this CH3COOH is mixed with CH3COONA, it acts as a buffer. This is a weak acid and it is a salt of this weak acid with strong base NaOH. So this acts as a buffer. So any weak acid, if you take HCl is a weak acid and KOH, KCl. So when this weak acid react with KOH, the salt KCN is formed. So that is act as a acidic buffer. So this is acidic buffer. This is the method direct mixing, or otherwise excess number of moles of weak acid is mixed with less number of moles of strong base, that also act as a buffer. So excess weak acid, so this is the first one. This is the second one to prepare. Excess number of moles of weak acid plus less number of moles of strong base. For example, if you are taking, that is number of moles of weak acid, is greater than, so number of moles of strong base. Number of moles of weak acid must be greater than number of moles of strong base, then it acts as a buffer. For example, so 100 ml of 0.2 molar CH3COOH is mixed with 100 ml of 0.1 molar NaOH. Here number of millimoles of weak acid is 100 into 0.2, that is equal to 20. Here number of millimoles of weak base is 100 into 0.1, that is equal to 10. So if you are mixing these two, this is CH3COOH is mixed with NaOH, then we get CH3COONA plus H2. So initially, so this is 100 into 0.2, 20 millimoles is present. This is 10 millimoles is present, 100 into 0.1. This is 0 millimoles. So water is neutral solution. At final, this 10 millimoles react with this. This is a limiting reagent. That's why 20 minus 10. This is 10 minus 10. This is 10 millimoles is formed. Finally, so we are getting this is 10 millimoles, this is 0, this is 10. So in a solution, weak acid 10 millimoles and its salt with strong base 10 millimoles is present. So it acts as a buffer. So excess number of moles of weak acid plus less number of moles of strong base, that also act as a buffer. For calculation of pH of this buffer, we are using Henderson equation. We can derive Henderson equation next. What is this basic buffer? Basic buffer means is a weak base. Similarly like acidic buffer. What is basic buffer? So basic buffer means weak base plus salt of this weak base with strong acid. This act as a basic buffer. For example, if you are taking NH4OH plus NH4Cl mixture directly, this act as a basic buffer. NH4OH is a weak base. This weak base react with strong acid HCl. We are getting NH4Cl. So this act as a basic buffer. For example, AgOH, so is a weak base. When it react with HCl, AgCl is formed. So this act as a basic buffer. So this is a basic buffer. So or otherwise, excess amount of weak base, less amount of strong acid is mixed. So case 2 how it is prepared means excess of number of moles of weak base plus less number of moles of strong acid. This also act as a basic buffer. For example, here also same example you are taking. So 100 ml of 0.2 molar NH4OH is mixed with 100 ml of 0.1 molar HCl. Then it acts as a buffer. Here it is 20 millimoles of weak base and 10 millimoles of strong acid if you are mixing. This 10 millimoles neutralizes 10 millimoles of weak base to form a salt. So that solution containing some weak base and its salt with strong acid. The solution containing weak base and its salt with strong acid. So it can be act as a buffer. So this is another method to prepare buffer. So this is basic buffer. Now let us explain buffer action of acidic buffer action of basic buffer. Okay, na? So now let us explain buffer action of acidic buffer and buffer action of basic buffer. How these act as buffer? That means if you are adding small quantity of strong acid or strong base, there is no change in pH of this acidic or basic buffers. How it act as a buffer? This buffer action and Henderson equation for calculation of pH of acidic buffer and pOH of basic buffer. Let us see in next class. Okay, thank you.